Name this compound. What is Uf6? Uranium hexafluoride. So this is a uranium atom covalently bound to 6 fluorine atoms. Okay, so we look at our rules. This is obviously not a pure compound. It's not got an oxidation number of 0. It's 2 things. For the first rule, we can skip right to the fluorine rule. We've got fluorine. So fluorine has always got an oxidation number of what in all compounds, always and forever and ever, amen? 1. -1. So we typically write that over there. All right, and I'm going to do this as a means of formatting. So I have an oxidation number of -1. How many fluorine atoms do I have here? 6. Gives us a total negative oxidation number of -6. That's for all the fluorine atoms. Each one has got a -1. Now, I know that x plus -6 has to equal 0. Because I know the algebraic sum of the oxidation numbers have to equal 0. You can all do this in your head. You can all do this asleep, hanging upside down at 2 in the morning. It's going to have +6 oxidation on the other side to balance it. Now here comes the question. How many uranium atoms do we have?
1.
Just 1. So, dividing by 1, we get +6 is our oxidation number. So the way that's traditionally written, we would write it like this. Oxidation numbers are written directly over the number, not off to the side like charges. And we put the positive or negative sign first, not afterwards like charges. So it's one more thing that distinguishes them from charges. Okay, pretty easy, right? And this actually is. It's just following rules. It's just plugging into different rules. So let's practice a few more. Okay, H2SO4 was done for us. Let's do PCl5. Name that compound. Phosphorus what chloride? Phosphorus Pentachloride. Think of the pentagon. Okay? Phosphorus Pentachloride. So, when we look at this, there's no specific rule for either of these. Let's look at our very first rule after we get past the zeros. Take the more electronegative thing, assign it the oxidation number of the charge it would have, and go from there. So, if chlorine was going to make an ion, what would its charge be? -1. So, how many chlorines do we have? 5. Okay. Once again, this is not rocket science level math. We know that we have to have a +5 over here to balance. Well, we only have 1 phosphorus, which means that phosphorus is going to have an oxidation number of +5. Okay? Actually, let's set this aside for the moment. So we've got P +5 Cl -1. We'll come back to that. We're going to use that later. Okay, let's do one more of the simple ones, and then we'll step it up a notch. Okay? Let's do PCl3. Okay. Huh? Phosphorus Trichloride. Yeah, good. So we had phosphorus pentachloride. Whoops, I forgot to put 5 there. And now we have phosphorus trichloride. So what's chlorine's oxidation number going to be? Pardon? -1. Right. Okay, so -1 times 3, we have -3. What do we have to balance that? Duh. +3. So, okay. And we'll set this one aside too. Okay, so pretty easy, yes? What if we have what is it? Name it.
Sulfate.
Sulfate ion. Sulfate ion. So suddenly we're not dealing with a neutral compound anymore. We're dealing with a charged polyatomic ion. We'll pause this and come back after the bell, after break.